Okay, it's 11 now. Okay, let's get started. Okay, we are still waiting for two of them, but because of time, we start punctually. Very good that you come on time. Okay, now just want to get to know you a bit better. Which school are you from? Which school are you from?
SKPS.
Huh? Which school?
SKPS. Sengkang Primary School.
Sengkang SKPS. Sengkang Primary School. Oh, okay, Sengkang Primary School. And what's your CCA? What's your CCA?
You know robotics?
Robotics.
Yeah, that's my favorite CCA.
Okay.
I'm actually in it right now.
You're in it, you're in robotics CCA now.
Yeah, I'm ICT. That's what we call it in the school.
Okay, robotics. Okay, now let's take a look at these questions. Worksheet 6. Okay. Okay, let's look at question 1. Have you watched the video already? The video for the lesson? Can't hear you. You're muted. Yeah. Have you watched the video of the lesson?
Yeah.
Watch it, right? So, done the worksheet?
Would you like me to highlight my answer?
Yes, you can highlight. But let me read the question first. Okay. Which of the following does not help? Let me draw in here. Does not. Keyword here is not. Does not help in the conservation of.
Sorry about that.
Is it use solar powered cars? Eat less food.
That one helps. That one 100% helps.
Switching off all electrical appliances when not in use. Take public transport instead of driving your own vehicle. So conservation of energy, you conserve energy. So B, eat less food and throw the rest away. This one I don't conserve because you throw in the rest away. When you throw, you don't conserve anything. You're actually wasting it. Okay. Use solar powered cars. Solar powered cars, you
help a lot.
Yeah, you save yourself from burning fossil fuels.
Yeah.
Because normal cars, internal combustion engine. You know what is the opposite of solar powered cars?
Yeah, the kind of cars with those
Yeah, called ICE car, ICE cars. ICE cars stand for internal combustion engine. Internal combustion engine.
Combustion means like burning of fuels like that, right?
Correct. So they burn fossil fuels like petrol. You put in petrol, they burn fossil fuels, and then they use the burning, right, to create a small explosions, create chemical reaction that propel the car forward. Okay. You switch off all electrical appliances are not in use. This one also saves on electricity. When you save electricity, you burn less fossil fuels.
Yep.
Because most fossil fuels, you know where most of our electricity comes from?
Fossil fuels.
Fossil fuels, correct. Okay. Because most power plants, they are powered by fossil fuels. And take public transport, okay, instead of driving your own vehicle. For the same 4 wheels, right, that you have your car in, for the same amount of space taken, a bus can take 50, probably about 50 people. A vehicle can only take about, car can only take about 1, up to 4.
No, they usually about until 6 if you squeeze in very tightly.
Yeah, if you squeeze, can only squeeze 6 people. So a bus is much more efficient in terms of transporting people. So environmental wise, right, take public transport is always better. Yeah. Do you own a car?
Oh, no, I'm still a kid. How to own a car?
Does a
I don't
parent
have
own a
like
car?
this license yet.
Does a parent own a car?
No, we actually cycle.
Oh, your cycle. Yeah, cycle is also environmentally friendly.
Yeah. And
Because-
then what's even better, we don't waste any fossil fuels.
Correct.
Because buses still burn fossil fuels.
Correct. Buses still burn.
So in a way, cycling is a bit more better.
Cycle runs on your fuel.
Oh yeah, in a way it does, but then it's on food. So yeah.
Food.
It's
Yeah,
on
the
food.
fuel is food for cycling. Yeah.
Yeah.
Okay, now let's look at the question 2. Okay, question 1 is B. This one is B. This one is quite easy. Very B. Let's look at question 2. Diagram below shows a sky lantern. This one is quite often when you see in Taiwan. Taiwan, there's a sky lantern. Sky lantern is made of paper. There's a covered top and an opening at the bottom. So which one of the following correctly shows the energy changes when the candle is lit and the sky lantern rises up into the air? So which one? Okay, you chose D. Let's look at the other options. A, look at A. Start with light energy. So like kinetic energy, heat energy, sound energy. Changes when candle is lit and the sky lantern. So where does do we start with light energy?
Nope.
The starting point is the fuel in the candle, right?
Yeah.
The candle is a fuel. So actually you don't start from light energy because candle is a fuel. Okay. Start with kinetic energy also wrong.
Yeah.
Because there's no movement at the beginning. Okay, when you lit the candle, there's no kinetic energy. Chemical potential energy, the candle, right? There's chemical potential energy. And you burn it, it becomes light plus heat, correct? Light plus heat, correct? It's also, after that, it rises, have gravitational potential energy. Okay, also correct. But there's one missing.
Yeah, but then there's nothing. There's no kinetic energy.
Correct. There need to be kinetic energy, KE. So there's a missing energy because the lantern moves up, right? So the movement, that means there's kinetic energy, there's movement. Okay. So there's movement, there's kinetic energy. It moves up. Okay. So as it moves up, it gains gravitational potential energy. Okay, it gains. Okay, so it's D, correct? Okay. Now let's move on. Okay, when the battery of a handphone is fully charged, it is unplugged from the socket. Which one of the following represents the energy conversion of the handphone when it is switched on? So when you plug it, it comes from the socket and it charges the phone, correct? Okay, let's look at the 4 options. First, heat energy. Does it start with heat energy?
Like that.
Doesn't, right? Doesn't start with heat energy. So A is definitely wrong. Don't start with heat energy.
Why kinetic?
B, kinetic energy. Movement. There's no kinetic energy here. The whole system, there's no kinetic energy. So also wrong. Electrical energy, is it possible?
Nope. We need the chemical potential energy first.
Yes, we need the battery because it's from handphone. Handphone start from chemical potential because got battery inside. Okay, so we start from chemical potential. So this is where the potential energy is, handphone. And then the chemical potential energy convert to electricity, which is electrical energy. And then convert to light and sound energy. When you can see the screen, light and sound. Okay, so the answer here is D, option D. Okay, now let's look at the next question. Okay, study the actions listed below. Okay, 1 is burning a lot of wood. 2 is dropping a ball onto the floor. 3 is rubbing your hands together like this. Rubbing your hands together. 4 is switching on an electric table fan. Which of the following shows the energy conversions of all the actions correctly? Okay, looking at the first one, burning a lot of wood. Burning a lot of wood, do you convert kinetic energy to heat energy?
Nope.
Wood don't have kinetic energy. A lot of wood. There's no kinetic energy. So first one is wrong already. Okay. So those with kinetic energy at the beginning is sorry, some may not be wrong. It's one. One side of kinetic energy is here wrong.
Yep.
So dropping a ball onto the floor. Drop a ball is type of kinetic energy. After it drop, become heat energy. Does it become heat energy when drop to the floor? Possible. Rubbing your hands together, kinetic energy to electric energy, not possible because our rubbing don't generate electricity.
Yeah, then we get electric shock already.
Yeah, correct. So switching on an electrical table fan, kinetic energy, now it didn't change the potential energy.
Yeah.
So option A is wrong. Option A is wrong. B, potential energy, lot of wood, okay. Lot of wood is a fuel. Fusion and heat energy is correct. Dropping a ball from potential energy to kinetic energy is correct. Rubbing your hands together, kinetic change to heat, correct. And switching on electrical fan, electrical change to kinetic, correct. So answer is B. Let's look at C. C, first one, kinetic is wrong already. Potential to heat also wrong. Potential to kinetic also wrong. Electrical to kinetic also wrong. Okay, sorry, this one is correct.
Oops. I think I accidentally wrote it. That's wrong. Sorry.
It's correct. Electrical connection. So this one D, right? For D is wrong. Dropping a ball, kinetic to potential. It should be potential to kinetic. This is also wrong. Potential to heat energy. It's not potential, it's kinetic to heat energy. It's also wrong. Kinetic to electrical energy. It's also wrong. It should be to kinetic energy. Electrical energy to kinetic energy. So the answer is B. Okay, B. Okay, let's move on.
Okay, let me see.
Okay, why not you read now? You read for us this time. Joanne?
Joanne left a remote control car near the bottom of a slope, as shown below. Once she pressed the forward button on her remote control, the car moved forward. She then pressed the stop button on the remote control, but the car continued to move forward and up the slope before falling to the floor. Which one of the following correctly shows the kinetic conversion in the car after she had pressed the forward button on her remote control?
Okay, so which one? The first type, kinetic energy. Okay, do you start with kinetic energy at the beginning? Then change to potential energy.
Yep.
And change to kinetic energy again. And to sound and heat energy. So at first one is wrong because first one you don't start with kinetic energy. Okay, there's battery in the car. So battery, that means there's potential energy instead. So first one is wrong. So second one, electrical energy. Right, start with electrical energy. The battery, before the battery change to electricity, there is chemical potential energy, correct? So you start with potential energy first, not electricity, electrical energy. And change to kinetic, and change to potential, and kinetic, sound and heat. Okay, so this is also wrong because you don't start with electrical energy. Okay, C, or you colored the C a bit. Potential energy first, then start with electrical energy, convert to electrical, then kinetic energy, and potential energy, kinetic plus sound plus heat. Okay, correct. Okay, D, start with potential energy, correct. Then change to electrical energy, kinetic energy, potential energy. Okay, compare C and D, what's the difference?